let's start with the Weierstrass form. Write gamma n of z as 1 over z e to the minus gamma z, product n equals 1 up to capital N, n over z plus n e to the z over n. That's e to the z into minus gamma plus the sum 1 over n, little n 1 up to n. Let's subtract off log n and put it back as an n to the z there. Have an n factorial from those terms and z plus 1 up to z plus n. We know that the sum 1 over n up to n minus log n tends to gamma as n goes to infinity, and hence gamma z is the limit n goes to infinity of n to the z n factorial z plus 1 up to z plus n, which is the Euler form. We also have Stirling's approximation, which we can write as the ratio of those two terms goes to 1. So gamma of z is the limit n goes to infinity. We can replace the factorial there by Stirling's approximation. And that's what we'll be using. So define that thing to be gamma subscript n of z now. And I've used the same notation here, but from now on that's gamma n. Okay, we want to look at gamma n of z, gamma n of z plus 1 over m up to gamma n z plus m minus 1 over m. So that gives me 2 pi to the m over 2 e to the minus n m, n to the mn mn plus m over 2, plus from this term we get mz plus m minus 1 over 2, since the sum n equals, I should put k equals 0 up to m minus 1 of z plus k over m is mz plus a half m minus 1. I need to put in the product here. We have the product from, say, k equals 0 to, actually let me write this thing in first. We get, that is actually n, z plus, z plus k, z plus 1 over m plus k up to z plus m minus 1 over m plus k. Okay, that's 2 pi m over 2 e to the minus n m n m n plus m over 2 plus mz plus m over 2, so cancels that with that, minus a half. I multiply this top and bottom by m to the m, so I get m to the m n plus 1 times the product 1 over mz plus all integers k from k equals 0 all the way up to the top one, which will be mn plus m minus 1. Okay. Next, let's take a look at gamma nm mz. That thing is 2 pi to the 1/2 e to the minus nm, nm to the nm plus a half plus mz times the product 1 over mz plus k, k equals 0 up to nm. Therefore, the ratio is 2 pi to the n minus 1 over 2. The e to the nm's will cancel off. We have an n to the nm plus n plus mz minus a half m to the m n plus 1, and let's divide it by n to the n m plus a half plus mz m to the m n plus a half plus m z. The product term is 1 over mz plus all values of k from one more of this, so that's mn plus k, all the way up to the top term in the other series, which is on the other piece of paper, but that's m minus 1. We're looking at the limit as little n goes to infinity. It'd be convenient to have an mn here, and if I do that, I have mn to the n minus 1 down here to cancel that off. So this gives 2 pi to the n minus 1 over 2. That cancels with that. That cancels with that. We have a 1 over n. We have m to the n, and that cancels with that. We have m there, half minus m z, and we have mn to the 1 minus n. I've got an n to the m there as well, so actually that, and that all cancel. What else? Oh, that's an m to the m in there as well, which I haven't accounted for, so that just gives me an extra m. So that should be a minus sign. So that will actually change that to a plus. That goes away. That goes away. Times this product. But that thing goes to 1 as n to infinity. So as n goes to infinity, this gives me gamma z. Gamma z plus n minus 1 over m is 2 pi to the m minus 1 over 2 m to the half minus mz gamma mz, which is the Gauss multiplication formula. Now, had we just known that this limit here, that this quantity here, divided by m to the minus mz gamma mz, if we knew that that thing was just, let's put subscript m on, was a function of n and z which has a limit independent of z, then we would know that gamma z plus m minus 1 over m would be equal to f m minus mz gamma of mz. We need to find f. Well, we can take z equals 1 over m in here, and we'll get gamma 1 over m, so gamma m minus 1 over m times gamma 1 is f m to minus 1 times gamma 1. Okay, we're going to use gamma z, gamma 1 minus z is pi cosec pi z. With z equal to k over m for k equals 1 up to m minus 1, and so this term is greater than 0. So in here you can pair up individual ones. You might have an odd one in the middle, which will give you gamma half, which is root pi, which is greater than 0. So actually we know that f is greater than 0. What we can do next is use z to the m minus 1 over z minus 1 is z minus omega to the n minus 1, where omega is e to the 2 pi I over n, and then take the limit z goes to 1. By L'Hopital's rule, this is just n, 1 minus omega to the n minus 1, and that's equal to the modulus of 1 minus omega to the n minus 1, and we know that the modulus of 1 minus e to the I theta is e to the I theta over 2 modulus times 2 sine theta over 2. So m is 2 to the n minus 1 sine pi over n sine n minus 1 to be n. Therefore, f squared is gamma 1 over m, gamma n minus 1, gamma n minus 1 to the n all squared, and there's an m to the minus 2 there. So that will just give me pi to the m minus 1 cosec pi over m cosec 2 pi over m up to cosec m minus 1 pi over m. Pi to the n minus 1. The product of all of these things will give me 2 to the n minus 1 divided by m. So f is 2 pi to the n minus 1 over 2 m to the half, and therefore gamma z plus m minus 1 over m is 2 pi to the n minus 1 over 2 times m to the half minus mz gamma mz again. which is the Gauss multiplication formula.